Today we're looking at a piece of hardware that keeps the world running while it's literally being shaken to its core.
Right.
We've got the data sheets here for the NTI ST-M12V-R-600. I know it's a mouthful of a name.
It is, yeah.
But the mission here is really specific.
Yeah.
Broadcasting high-res video in places that would just, absolutely destroy a normal computer setup.
Exactly. We are talking about bridging that gap between delicate silicon and just brutal industrial reality. Think about rail transport, factory floors.
Places with constant, unforgiving vibration.
Mm-hmm. And that's the whole challenge.
And that's the hook for me. I mean, if I just nudge the VGA cable on my own desk, the monitor flickers. This thing is designed for a train rattling down a track.
Right, and looking at the specs, you can see the secret sauce is the interface itself.
The connector.
It's the connector.
Yeah.
A standard monitor cable relies on friction, maybe 2 tiny thumb screws. This unit uses 8-pin A-coded M12 connectors.
Which is a standard you see a lot in automation sensors and things like that.
Yeah, exactly. A coded just means it's keyed for sensors to prevent, mismating. But the real magic is that it threads on and it locks.
So it creates a mechanical bond.
Yes. You aren't just plugging it in, you're literally screwing it onto the chassis. It becomes almost completely immune to vibration.
So you lock the connection at the box. But this isn't just a fancy coupler. It's a whole split and extend system.
Mm-hmm.
You have the broadcast unit, the VUPEX, at the source, say, the train's main computer, and then this Extendix remote unit out at the actual display.
Correct. And the bridge between them isn't some thick, expensive video cable. It just uses standard CT5 or KT6 network cable.
Which has to solve a huge routing problem. I mean, pulling a thick VGA cable through a train carriage wall sounds like a nightmare.
It is. Ethernet cable is flexible, it's cheap, but you still have to deal with physics. We're talking about sending an analog video signal over twisted pair copper for, what, up to 600 feet?
Yeah, the datasheet says 600 feet. So what happens to the image quality at that kind of range?
Well, you do hit a trade-off. At shorter ranges, say around 100 feet, you're getting 1920 by 1440 resolution. It's crystal clear.
Yeah.
But as you push toward that 600-foot limit, the signal degrades. You drop down to 1924 by 768.
That's a pretty big drop, but probably fine for a next stop sign or a factory status board. Readability is more important than 4K fidelity there.
Precisely, and NTI actually accounted for that. The remote unit has a manual video quality adjustment. It's basically an equalizer.
So you can tweak it.
You can physically tweak the signal gain to sharpen the image based on the exact length of cable you've run.
I do want to circle back to the format, though. This is a VGA splitter.
Yeah.
In an age of HDMI and DisplayPort, isn't VGA a little antique?
In the consumer world, yes. But in the industrial world, not at all. There are thousands of legacy systems, SCADA controls, transportation computers that were built on VGA, and they're going to run for another 20 years.
They need reliability, not the newest standard.
That's it. Reliability is everything.
And that seems to be the theme of the build quality, too. The housing specs here say rugged steel with a powder coat finish. And the temperature range is massive.
It's -4 to 158 degrees Fahrenheit.
So from a dead of winter, unheated train car
to the ceiling of a foundry in July, it handles both. And since we keep mentioning trains, it's also compliant with EN 5012132.
which is the European standard for railways.
Right, for electromagnetic compatibility on rolling stock.
So the massive electrical spikes from the train's engine or the brakes won't fry the video splitter.
Exactly. Plus, it has immunity to electrostatic discharge. It's just hardened against all the electrical noise you find in industrial zones.
And one detail we shouldn't gloss over is the audio. It's not just video.
Right. It supports stereo audio through terminal blocks. So if that digital sign needs to play a chime or make a voice announcement, this one cable run handles CD quality sound right alongside the video.
It's just a reminder that real-world infrastructure isn't always about the newest chip. It's about the strongest link in the chain.
That really is the takeaway. You can have the smartest computer in the world, but if the connector shakes loose, the screen just goes black. This device is purely about fighting physics to keep that connection alive.
So next time you're on a rattling train and the next stop screen is perfectly stable, maybe spare a thought for the humble M12 connector holding it all together. Thanks for listening to this deep dive.